Good evening, ma'am.
Good evening. Hello, here, Harshita Dakshin and Neha. Harshita, you always join from two devices.
Yes, ma'am.
Okay. One is for camera, other is for speaker. That's why.
Ma'am, no, ma'am. One is for large screen and another one is for speaker and sound.
Okay. Let's recapitulate what we did yesterday. Uh, Expansion. So, Harsha, tell me, what do you mean by expansion and the daily life examples? What is expansion and how it is useful to us?
Ma'am, expansion is like becoming in bigger size.
Okay. What are the factors required to do to expand an object?
Ma'am, by heating.
By heating, okay.
Ma'am, by blowing the balloon.
By blowing the balloon, fine. Neha, any other example?
Ma'am, can you hear me?
Yeah, now.
Ma'am, on freezing.
Good evening. Neha, are you telling something?
Ma'am, on melting. Ma'am, ice melting into water.
Ice melting into water is expansion, okay. Or fine. Now listen. Suppose you have to unscrew the cap, the lid of a glass jar, and you are unable to do so. Then one of the method to unscrew it, like little bit, heat it very to a very low increase in temperature, but heat a little bit. It will expand in size and will then become easier to unscrew. Or you can just run some hot water onto the metal lid for a few seconds so that it gets little high in temperature and it slightly expand in size, and then it will definitely become easier to unscrew. Okay, now see few examples I'm sharing. I hope it's visible.
Yes, ma'am.
Hmm. So expansion in solids is mainly seen in railway tracks that consist of two parallel metal rails joined together. Okay. If you have ever noticed, they have a very small gap between the two consecutive tracks. Have you noticed this? Look at the circle, red circle, visible.
Yes, ma'am.
Hmm. I'm telling that these horizontally placed two tracks are joined with some other piece of metal, but there we can easily see some gap. Next time if you visit railway station, please notice. So this small gap called expansion gap are deliberately left. Actually, this is, this gap is not like left by chance. It is knowingly kept here because in like month of June and July, when the temperature rise to almost 45 to 50 degree, we know metals, every type of material expand. This railway track will also expand. In case you do not leave any gap, what will happen? You know, so this is knowingly left so that if when they expand, they get some size to properly set, and so that they just come and touch each other. and no other harm can be there to the trains and all. Read it out.
Ma'am, should we write it?
Oh, you can. Written expansion in solids.
Yes, ma'am.
Okay. Next, look at expansion in liquids. Okay. So we know that every matter expands on heating. Water also expands on heating. Now, please do not try this. Okay, I'm cutting this line. Now take a glass filled with water to its brim. Pour the water into a container. Okay, you have to take a glass, fill it with water to its brim up to the topmost level. Pour the water into a container and heat it. Do not boil. Now try to pour the water back into the same glass. The water overflows. Okay, this you can try. I'm sorry, this you can try. The one I was telling yesterday was some other activity. Okay, this you can definitely try. It is very simple. Like you have to measure water up to the level of any one single glass. Now, take it into another steel or metal pan. Heat it. Do not boil. Just heat it to a little high temperature, and pour that water into the same glass. Because while we heated the water, it got expand to a little bit more. Then it is supposed to occupy a little more space. So if we pour that same water back into the same glass, it is expected to overflow. Are you getting?
Yes, ma'am.
Hmm. You can try this activity. Please note, do not heat the water too much. A very slight heat. But please note this also, that you have to try this activity with the help of an adult. Tell them what you are going to do. Tell them what you want to try. Noted? Expansion in liquids.
No, ma'am, 1 minute.
Now written, be quick 6 class.
No, ma'am. Ma'am, 1 minute, I'm in this.
Done. Okay. Now expansion in gases. If you keep an inflated balloon in the sun, okay, because sun heat is, we all know that how much it can heat we have the experience in the summer. If we are not able to stand in sun. So it is enough to heat any object. For some time, what will happen? It will grow in size as the air inside it expands on taking heat from the surrounding. So you can try this activity also. Because now already, the temperature is already so high. You can try expansion in gases also.
Ma'am, it's winter, right?
Hmm?
Ma'am, it's raining. Like,
It's raining at your place.
ma'am, where do you live?
I live in Delhi. You?
Ma'am, that means it doesn't rain over there. I
No.
live in Hyderabad, ma'am.
Okay. It is not necessary. It means if Hyderabad it's raining, it's not necessary, it will rain in Delhi also. Noted expansion in gases.
No, ma'am. Done, ma'am.
Done? Okay.
I'm not done. 1 minute.
After this, because the topics following NCERT are already covered, we'll solve the exercise. Okay. And for homework, I have a worksheet for you. Should I change now? Should I change the slide now?
No, ma'am. 1 minute.
It's class B, little quick noting down, okay? Hope it is now done. Here comes contraction in solids. Uh, Contraction means adaptation written.
Contraction means it's it's suppressing, ma'am.
Huh?
It's suppressing.
I'm not getting.
Ma'am, it's shrinking in size. It will become smaller, ma'am. It will decrease.
Okay, okay, okay. Earlier, were you using any other language?
No, ma'am.
Okay. I thought it's a regional language.
I'm suppressing, I have told.
Okay, okay, suppressing. Fine, fine. Yeah. So a condition for contraction is condition to contract an object. How can we do that?
Ma'am, release air out of a balloon.
No, no, no. Means in general condition. Don't tell me the particular, but general. By bringing down the temperature of object.
Yes.
By lowering the temperature, right?
Yes.
So let's see contraction in solids. This I was telling yesterday. So I'm clearly mentioning here, do not try. Okay. You can just see what happens actually. If we hold a very hot glass tumbler under cold water, it cracks. Means suppose I just poured a tea into a glass, then I wish not to use this glass. I already emptied that, poured in another container, and immediately, brought it under the running cold water. What will happen? The temperature already rose to a little high value when we poured that hot tea into the glass. Then immediately bringing it under the running water, the temperature brought so down. So because of this, because of contraction, the glass will break. Okay.
Does this happen to a steel glass also?
No, not steel. It is for glass. Glass. This is because the outer surface of glass comes in direct contact with the cold water and contracts more as compared to inner surface. So due to the temperature difference between the outer and inner surfaces, such will happen. Fine. Next, contraction in liquids. Okay, note down solids. Or
I'm done. I'm done.
okay. Contraction in liquid. We observe that water expands on heating. Can you say what will happen if the water is allowed to cool down, or simply if you refrigerate and then pour back into the glass? Now, uh, on the reverse case of the previous expansion one, we can say that this time the water should remain to a little lower level if we cool it into the same glass, isn't it? What do you think?
Explain it again.
In expansion, when we heated the water to a little high temperature, then again poured that into same glass, it is expected to overflow because we are assuming that the water will expand. Okay, it is supposed to take little more space than the size of glass which we measured. Now, if the same amount of water we refrigerate, we bring it down to cooling process, then uh, definitely it will not expand. But do you think that its level will become little lower or it will remain same? Would it
Lower, it will lower.
No, definitely no. This is because of contraction. So you can say that it will remain to a same level, or try to notice if you observe any reduction in its level or not. You can try this activity also, okay? Is it fine?
Yes, ma'am.
Whichever glass you are taking to measure, take the transparent one and put a mark with any pen or anything, or like put a sticker or something, and refrigerate it for at least 1 or 2 hours, and then pour it same in the same glass in the notice. And contraction in gases. If an inflated balloon is tied at the mouth of bottle and bottle is placed in ice cold water, what will happen? Earlier, we placed an inflated balloon in sun, and because of sun's heat, the gas is expected to expand. So we can say the balloon will, increase in its size. What will happen if we do not tie the balloon, but we tie it at the mouth of bottle and place that bottle in ice cold water?
Now it will shrink.
It will shrink. So you can try.
Because it sucks all the air into it
Yes.
from the balloon.
Correct. So please try, and if possible, try to capture the pictures also before after, like with placing an inflated balloon in sun. So before this much, the balloon was this much in size, and after keeping in sun for half an hour or 1 hour, it became this in size. The proper activity, you can make just a simple image or PPT of your own.
Okay.
Okay. It will be interesting actually. No need to write anything. Just your name, capture the images, and put the heading, contraction, expansion, whatever.
Okay, ma'am.
Please note down quickly. Noted.
No, ma'am. 1 minute.
Ma'am, I'm doing.
I hope you all have NCRT.
Yes, ma'am.
Okay. Open back exercise quickly. Should I stop sharing the slide?
Yes, ma'am.
Yes, ma'am. Over.
Open back exercise of same chapter.
Ma'am, what is the chapter number?
Changes around us. The chapter number might differ. You look, changes around us, chapter name.
Ma'am, there isn't any chapter named that.
Else I'm sharing on screen. Hold on.
Ma'am, are you saying air around us?
Changes around us.
Ma'am, there's only chapter named air around us, no changes around us.
Look.
We don't have this chapter.
Ma'am, we don't have this chapter.
Okay. Air around us, you people have?
Yes, ma'am.
Fine, that's fine. For now, you can refer to the screen I'm sharing. First, to walk through a waterlogged area, you usually shorten the length of your dress by folding it. Can this change be reversed? Keep answering. Too simple.
Ma'am, it can be reversed.
You accidentally dropped your favorite toy and broke it. This is a change you did not want. Can this change be reversed?
No, ma'am.
Yes, ma'am.
No,
It,
ma'am.
it depends.
Ma'am, it can be repaired. Ma'am, it can be repaired.
How?
I'm fixing it.
But it will not appear the same way it was earlier.
No, ma'am.
Yeah. So it cannot be reversed. Next.
Okay, ma'am.
Not listed in following table. For each change, write whether it can be reversed or not. Sawing of a piece of wood.
No, ma'am. It cannot be
No, ma'am.
changed.
Okay. Neha, Dakshin, and Harshit, all three are supposed to answer. Melting of ice candy?
Ma'am,
No,
it can.
Ma'am, ma'am, it can.
Ma'am, it can.
Yes,
Ma'am, it can,
reversible.
ma'am. Ma'am, it's a
Reversible.
reversible change.
Melting is just right. Dissolving sugar in water
Yes, ma'am.
Ma'am,
Yes, ma'am.
again can be reversed. Cooking of food,
No, ma'am. No, ma'am.
no, ma'am. No, ma'am.
chemical change. Ripening of mango,
No, ma'am. No, ma'am.
No, ma'am.
irreversible. Souring of milk,
No, ma'am.
No, ma'am.
No, ma'am.
no. A drawing sheet changes when you draw a picture on it. Can you reverse this change?
Ma'am, it depends on which pen. If you are using a pencil, it can. If you are using a
If-
pen, it can't.
Correct.
Yes, ma'am.
So this way you can explain it in your own language. Next, 5 examples to explain the difference between changes that can or cannot be reversed. So think of example. Each one of you has to state one example of each.
Ma'am, can I say?
First, Harshit.
Ma'am, can is dissolving sugar in water
Hmm.
and cannot is breaking of glass.
Breaking of glass. Break. Other action.
Cutting clothes, ma'am, like into small pieces.
This is can be or cannot be.
Cannot be, ma'am. Irreversible.
Okay. Can be example.
Ma'am, can be.
Hmm. There are many examples. You can think of any physical change because usually physical changes are reversed.
Ma'am, can I say?
A reaction only. A reaction, come on, there are so many examples.
Yes, ma'am.
Physical changes, change of state of matter, any of it. You can think of evaporation, condensation, folding up of clothes, rolling of dough into a flat circle.
Ma'am, clothes.
Fine, it's okay. Neha,
Yes, ma'am. Ma'am, reversible change example is um, ma'am,
I missed it. Pardon, please.
ma'am, melting of ice.
Okay.
An irreversible change is formation of curd from milk.
Good. Correct. Okay. Look at a thick coating of plaster of Paris is applied over the bandage on a fractured bone. It becomes hard on drying to keep the fractured bone immobilized so that it cannot move. Can the change in POP be reversed? Means the way we prepare that plaster, can we get the POP out of it in the same way? Have you ever seen the POP, the white material, which keeps on hardening with time?
No, is it casting?
The more it keeps on drying, it becomes hard.
No, ma'am.
Ma'am, I don't know plaster of Paris.
Okay. Other two,
Ma'am, I don't know.
don't know. Neha,
Ma'am, Ma'am, I think it cannot be reversed.
It cannot be reversed. POP is the same material with which we use, it is a one which is used to design the ceiling of your room. The white colored material, although we can color it later on, but that white color substance which gets hard with time. The same is applied on a fractured bone, okay? Because it becomes so hard that the way doctor fix our bone into that POP, the bone will remain in the same position as it is not supposed to move, so as to fix the bone. Okay, so we cannot get the POP back.
Yes. Ma'am, you did not ask me that can or cannot.
I asked all three of you. You said I don't know what is POP.
I'm not POP, that fifth one. Can or cannot.
Which one? All three of you have answered here.
Ma'am, I did not answer.
Okay, tell me now.
Ma'am, examples of reversible changes: healing of wound, healing of a wound.
Okay.
Ma'am, and examples of irreversible changes is cracking of an egg, to make omelette,
Okay. Good. Good. Seven. A bag of cement lying in the open gets wet due to rain during the night. The next day the sun shines brightly. Do you think the changes which have occurred in the cement could be reversed? What do you think?
No, ma'am.
Ma'am, no.
No, ma'am.
All sure?
Ma'am, it could be hardened.
Yes, ma'am,
Yeah,
it has
because
been
once the
hardened.
cement is wet, it gets hardened and we cannot get that same form again. Hmm. Now, I'll be sharing a worksheet today for homework. Wait, let me show you. Okay, few more changes are striking my mind. Do you know what is combustion?
Ma'am, what?
Give me some examples of objects which can
Did you
fire very easily.
Ma'am, can you repeat? Your voice is breaking.
I'm asking, state few examples. Tell me few objects which can catch fire easily.
Ma'am, wood.
Wood can catch easily. It can
Yes.
be burned, but not easily.
Ma'am, paper, cotton.
Paper, cotton, okay.
Ma'am, dry leaf.
Cotton can catch easily.
Ma'am, dry leaves.
Pardon?
Dry leaves.
Ma'am, camphor?
Ma'am, petrol.
Petrol, very good.
Ma'am, camphor?
Camphor, CNG, okay. Kerosene, okay. Why I'm asking you the names of these substances? This is to tell you that one more type of change which we should be aware of in general is, you can say combustion, where any object catches fire when brought near the flame. Few catch so quickly, few takes up time, like paper catch quickly, wood takes up time. Okay, so there's a slight difference, but yes, any material which can catch fire are known as combustible substances.
Ma'am, and if we keep camphor near the fire, it will attract the fire.
Yeah, that is also combustible.
Ma'am, and the fire goes near to it. Like if we keep it not far away, a little close to it, it will attract the fire.
Yeah.
Ma'am, but
So
plastic
how
is
can
not.
we define combustion? The burning up of substance in the presence of air, or you can say in the presence of oxygen. You can write air only. Okay. If there is vacuum, let's say in a room, although practically it's not possible to create vacuum, But if you can create and then, try to lit a paper and any other substance, they will not catch fire. Because for combustion, for burning of substances, presence of air is necessary. In presence of air only the process of combustion takes place. Is it okay?
Yes, ma'am.
And if you have ever noticed in trains and any public places, say flight or trains or like that, especially it is mentioned as a note and a caution that do not carry any inflammable substances. Noticed?
Yes, ma'am.
Inflammable substances means those substances which vigorously catch fire. The examples are petrol and CNG, kerosene. Okay, they like we do not even need to bring the flame near to them. Means at a distance they will catch fire. Okay, so that in order to keep safety and all those things in mind, we should not carry such substances in public places, especially in train.
Okay, ma'am.
Okay. Now, because in the worksheet I have mentioned, I have given this topic and fill in the blanks. Few things are there related to combustion. It's okay. Try to attempt all the questions. If you are not able to, then in the next class we'll be discussing definitely. Okay,
Yes, ma'am.
Okay, ma'am.
Okay, ma'am.
fine. Bye-bye. We'll meet in the next class.
Bye, ma'am. Have a nice day.
Thank you, ma'am.
Bye, ma'am. Have a nice day.
Bye, ma'am, for teaching.
Bye.
Bye, ma'am. Have a nice